All right, let's get right into it. Today, we're talking about something huge from NVIDIA. It's called Project GR00T N1. And this isn't just another small step, it's a massive leap. Essentially, they're building an open-source brain for general-purpose humanoid robots, one that can teach them to learn and act in our world just like we do.
And really, this all boils down to one central, massive question that's been haunting robotics for decades. How do you actually get a machine to learn skills in the real, physical world with anything close to the flexibility of a human? It's a problem that has been a brick wall for a very long time.
The ambition here is, honestly, the humanoid robot dream we've all seen in sci-fi. We're not talking about a machine that just does one thing over and over again on an assembly line. No, the vision is a true generalist, a robot that can handle all sorts of different tasks in our homes and workplaces, right there with us.
Now, to make that dream a reality, you basically need a recipe with 3 essential ingredients. First, you need the hardware, a versatile body. That's why the humanoid form is so compelling. Second, you need the software, an intelligent mind, a really powerful AI model. And third, you need an education, a vast worldly library of data to learn from.
But here's the catch. That third ingredient, the data, has been the killer roadblock. You know, language models had the entire internet to read and learn from. For robots trying to learn physical tasks, that kind of resource just doesn't exist. This leads to what the researchers call the data island problem.
And the researchers behind GR00N1 put it perfectly. This quote right here just nails the problem. There's no internet of robot actions to draw from. That massive, easily accessible well of data that fueled the AI revolution in text and images, it's bone dry for robotics.
So what is the data island problem exactly? Well, think of it this way. The data from one robot, maybe one with a simple 2-fingered gripper, is completely unintelligible to another robot with a complex 5-fingered hand. They're speaking different languages. Every robot model is its own isolated island of data, and there's been no way to bring all that knowledge together into one big ocean.
So how did NVIDIA get around this? Well, the first part of their brilliant solution is the brain itself. They didn't just use an off-the-shelf model. They designed a special dual system architecture specifically for a thinking, moving robot.
And this is where it gets really cool. It's kind of like the famous thinking fast and slow concept. You have System 2, the planner. This is the slow, conscious reasoning part. It's a vision language model that looks at the world, understands a command, and makes a plan. Then you have System 1, the doer. This is the fast, subconscious, instinctual part, a diffusion transformer that's just churning out fluid motor commands at 120 times a second.
So here's how a thought flows through the robot. An instruction comes in, let's say, pick up that cup. The planner, System 2, sees the cup and understands the goal. Then, it essentially gives a high-level nudge to the doer, System 1, which takes over and generates all the tiny, precise muscle movements to make it happen smoothly. That seamless handoff from reasoning to raw action is the key to getting movements that look natural and dexterous, not clunky and pre-programmed.
Okay, so you have a smart brain, but a brain without any life experience is pretty useless, right? So now we get to the second part of the solution, and this might be the most ingenious piece of the whole puzzle, their strategy for finally solving that data island problem. They call it the data pyramid. Let's build it from the bottom up. The base, the biggest layer by far, is made of web and human videos. Just tons of footage of people doing things, giving the model a broad understanding of how the physical world works. The middle layer is synthetic data from simulations and AI-generated video, which lets them scale up training. And then at the very peak, the smallest but most precious layer is real robot data, which grounds everything in reality. But wait a second, you might be thinking, how can a robot with metal claws learn anything from a YouTube video of a person baking a cake? Their bodies are completely different. Well, that's the magic trick. It's a technique they use called latent actions. It's a super clever way to analyze a video and infer the underlying pseudo-actions that are happening. Essentially, it treats a human in a video as just another type of robot body. And with that one insight, the entire internet of human video suddenly becomes the world's biggest textbook for robots. Okay, so we've got the dual system brain and the ingenious data pyramid. The theory sounds incredible, but the billion-dollar question is always the same. Does it actually work any better? Let's look at the results. First up, in simulations. And the results here are, well, they're not even close. GR01N successfully completed the tasks 50% of the time. The next best approach, diffusion policy, was way down at around 33%. That isn't just a small improvement, that's a massive leap forward.
But simulations are one thing. The real world is what matters. And this number, to me, is even more jaw-dropping. When they used only 10% of the real-world training data, GR00N1 still outperformed the old baseline by an average of 32.4%. That shows an absolutely incredible level of data efficiency.
Let me put that a different way, because this is the whole ballgame. With just a tiny sliver of training, the pre-trained GR00T model was already performing almost as well as the old model did after seeing the entire data set. This solves the biggest bottleneck in robotics. It means we can train robots on new tasks faster, cheaper, and at a scale we couldn't dream of before.
And here's where you see the flicker of real intelligence. The researchers noticed the model started doing complex things it was never explicitly taught. For example, to complete a task, it spontaneously figured out how to pass an object from its left hand to its right hand to get a better angle. That maneuver wasn't in its fine-tuning data. That's not memorization. That's emergent problem-solving. It's starting to build a genuine, flexible understanding of the world.
So let's zoom out. What does all of this add up to? We are watching a fundamental change in robotics. This is a huge, huge step towards the dawn of truly general-purpose machines, robots that can finally learn, adapt, and operate in our messy, unstructured world. So the key takeaways are these. First, the dual system brain that lets robots both think and act. Second, the data pyramid that finally solves the data scarcity problem. Third, the incredible gains in performance and efficiency that blow past previous benchmarks. And fourth, and this is so important, NVIDIA is open sourcing this, allowing the entire community to build on this work and push things forward even faster.
And this all leaves us with one last really big question to chew on. For the first time, we have a clear path for robots to learn from the gigantic library of human experience that we've been recording for decades. So if they can learn from us, from all of our collected knowledge and skills, what kind of world will they eventually help us build?